Hi everyone, today we talk about the worst part in AP chemistry that's called stoichiometry. So let us read this first simple questions. First one is how many grams of sulfur dioxide are in the 4-liter sample sulfur dioxide in STP? As we know, STP is standard pressure, temperature, and pressure. So each is standard, nothing. Okay, temperature is 25 Celsius. And the pressure is 1.00 atm. Perfect. So if we want to figure out how many grams in 4 liters sample liquid, we have to know the molar mass of sulfur dioxide too first. So everyone, let us continue. First we need to know the molar mass of the sulfur dioxide. So as we know, sulfur is 32, the oxygen is 16 but times 2, so the molar mass is 32 plus 32 equal 64. So as we know, the mole is shit. So as we know, 1 liter's water can solve 64 grams of sulfur dioxide. So if we have 4 liters water, it has to be 64 times 4, almost equal 206. So we got the answer A. Hello everyone, here is simple question 2. Still in stoichiometry. Calculate the volume of 2.75 mole solutions must make the 1.25 liters of the 0.15 mole solution. So here we go. As we know, we have to calculate how many molarities in 1 liters. First step is 2.75 molarity. This is a unit. But in here we have 1.25 liters. So we have to know how many moles in 1 liter. It should be 75 divided liter. So we can get 2.2 moles per liter. So in 1 liter water, there are 2.2 moles. Oh, that's why. No. 2.2 moles. So, but here we go. These creepy questions ask us need 0.15 molarity in the 0.25 liters water. So it's very simple because we just need to use the molarity times the mole to get the volumes of solute. As we go, the molarity mole is 2.25 and the molarity is 0.15. So we just need to use 0.33 liters. Convert 0.33 liters and to the millimeters, it's just 3 millimeters. So we can choose C. Everyone, this is the last question on the multiple choice part. So this question about calculate the mole of the sodium peroxide produce 32.5 grams of sodium react. So this is the formula for this reaction. As we know, we got 2 moles of sodium, 1 mole of oxygen, and 1 mole of sodium peroxide. They are the answers, so maybe let us choose one. Yeah, okay. As we know, we need to copy this first. But first, so we can know the product side and the reactor side has some different about the mole ratio part. This mole ratio is 2, this is 1, so the mole ratio is 2 versus 1. As we know, the mass of the sodium reactant is 32.5. Okay, this is X, but it's all fine because we don't need it. And the molar mass of the sodium is 46, oxygen 32, the sodium peroxide is 78. Okay, so here is 2 sodium, and the mass of 2 sodium is 32.5. As we know, the molar mass of the sodium is 23 times 2, 46. So the mole of the sodium should be use the mass divided the molar mass equal 0.7 mole. As we talked about, the mole ratio of the 2 sodium and 1 sodium peroxide is 2 and versus 1. So as we know, 0.7 mole is for the sodium, so this is 2, this is 1. So even the kids from elementary school, they also know 0.7 divided 2 equals 0.35. So let us find the answer from these questions. It should be second one, B. Everyone, this is the first full response questions. It's from the 2012, the question 1. The question about 1.22 gram sample of the pure monoprotic acid HA was dissolved in the distilled water. This HA solution was then treated with 0.25 molarities sodium hydroxide. This pH value was measured throughout the duration, and the average point was reached 40 milliliters sodium hydroxide solutions have been added. This data from the titration is recorded in table below. So let us look at the first questions. The first question is explain how the data in the table evidence that HA is a weak acid. So as we know, if a solution, the pH value less than 7, it should be acid. If larger than 7, it's basic. From this table, we can know this HA is a weak acid because the pH value is less than 7. Yes. Question B. Write the balanced neat ionic equation for the reaction that occurs the solution of sodium hydroxide added to the HA. As we know, HA is a acid and sodium hydroxide is a basic. So when they add together, should be have aqueous and H2O, water. So as we know, neat ionic equation so just include the ions that react in this reaction. So it should be HA plus OH, the hydroxide. So it will produce this A aqueous and this H2O liquid. Okay, let us start question 6. Calculate the number of moles of HA. So as we know, in the reactions, sodium hydroxide is 1 mole and the HA also is 1 mole. So the mole ratio of these two should be same. So the mole of the sodium hydroxide should be equal to the mole of HA. We don't know the values or the mass of the sodium hydroxide, but the thing we know is the value of sodium hydroxide is 0.04 liters. So as we know, the volume times the molarity equals mole. So the molarity is 0.25 liters per liter. So let us 0.04 times 0.25 equal 0.01 moles. So this is the mole of the hydrogen, the sodium hydroxide. The mole ratio of sodium hydroxide is same to the this is 1 to the HA. So the mole of HA is also should be 0.01 mole. Thank you. So this is the last question of this free response question. Calculate the molar mass of the HA. So as we know, calculate the molar mass, use the mass of the acid and divide the mole of the acid. As we just calculated, the mole of acid is 0.01 mole, and the mass of the acid they give us is 1.22 gram. So it should be 122 gram per mole. So the molar mass is 122. And because of we didn't start the acid and base part and the pH value part, so I cannot figure out the next question. So the number D should be our last question. Thank you. Based on the ice table here, we can get a formula for this is equilibrium formula Ka equal 63 minus power equal x divide 0.2 minus x. We assume the x is much smaller than 0.20, so we can just ignore this part. We can just not ignore this whole reactant part. It just ignores x in the reactant part to pretend this become 0.2. So we use this one times 0.2 to get x squared. So x equal so let us after we put this into calculator, so x should be equal 3.5 times 10⁻³ power molarity. Bingo.